Good day, I'm Luis Picmodo. I'm the one who will report about Cassegrain antenna. So, a Cassegrain antenna is a type of radio wave antenna. It's constructed in the style of the mirror telescope. The Cassegrain design is widely used in parabolic antennas, particularly in large antennas such as those in satellite ground station, radio telescope, and communication satellites. Brief history. The first Cassegrain antenna was invented and patented by Cochrane and Whitehead at Elliott Bros in Barham Wood, England in 1952. So the patent British number 700,868 was subsequently challenged in court but prevailed. Taking an excursus to the antenna theory, Cassegrain antenna is a double reflector system which works on the principle of Cassegrain optical telescope. The Cassegrain antenna design was adopted from the Cassegrain telescope, a type of reflecting telescope developed around 1672 and attributed to French priest Laurent Cassegrain. The Cassegrain design employ a parabolic contour for the main dish and a hyperbolic contour for the sub-dish. One of the two focuses of the hyperbola is the real focal point of the system and is located at the center of the feed. The other is a virtual focal point which is located at the focus of the parabola. Cassegrain reflector. So, Cassegrain reflector is a combination ng primary concave mirror at ng secondary convex mirror. So, ginagamit to sa optical telescope and radio antennas. So, yung pinaka-main characteristic being that the optical path folds back onto itself relative to the optical system primary mirror entrance aperture. Reflecting telescope. So, ang reflecting telescope naman, tinatawag din natin itong reflector. Isa siyang telescope na gumagamit ng single or a combination of curved mirror that reflect lights para makabuo ng image. The reflecting telescope was invented in the 17th century by Isaac Newton as an alternative to the refracting telescope, which at that time was a design that suffered from severe chromatic aberration. Cassegrain antennas are widely used in today's world of millimeter wave communication. So dahil sa high gain and pencil sharp beam width, ito yung kadalasang ginagamit para sa point-to-point link and mesh network terminal. Pero gumagana rin naman ito sa mga radar and satellite communication application. The fact of Cassegrain antenna's popularity is based on the general rule that if the diameter of the main reflector is greater than 100 wavelength, the Cassegrain system is a contending option compared to other antennas type. The main reflector is the most expensive part of the Cassegrain antennas and usually made from a metal-coated composite plastic or machined from a chunk of metal. In telecommunication and radar, a Cassegrain antenna is a parabolic antenna in which the feed antenna is mounted at or behind the surface of the concave main parabolic dish and is aimed at a smaller convex secondary reflector suspended in front of the primary reflector. So, parabolic antenna. The parabolic antenna is an antenna that uses a parabolic reflector, a curved surface with a cross-sectional shape of a parabola to direct the radio wave. The most common form is shaped like a dish and is popularly called a dish antenna or parabolic dish. So just like Cassegrain antenna, parabolic antenna are used as a high-gain antennas for point-to-point communication in applications such as microwave relay link that carry telephone and television signal between nearby cities, wireless link for data communication, satellite communication, and spacecraft communication antennas. They are also used in radio telescope. So the parabolic antenna was invented by German physicist Heinrich Hertz during his discovery of the radio wave in 1887. He used cylindrical parabolic reflector with spark-excited dipole antennas at their focus for both transmitting and receiving during his historic experiment. Parabolic reflector. The reflector can be a sheet metal screen, or wire grill construction, and it can be either a circular dish or various other shapes to create different beam shapes. A metal screen reflects radio wave as well as a solid metal surface as long as the hole are smaller than one-tenth of a wavelength. So screen reflectors are often used to reduce weight and wind load on the dish. To achieve the maximum gain, it is necessary that the shape of the dish be accurate within a small fraction of a wavelength. To ensure the waves from different parts of the antenna arrive at the focus in phase. Large dishes often require a supporting truss structure behind them to provide the required stiffness. Principle of operation. The standard definition of a parabola is locus of a point which move in such a way that its distance from the fixed point plus its distance from a straight line is constant. The following figure shows the geometry of a parabolic reflector. The point F is the focus, and V is the vertex. The line joining F and B is the axis of symmetry. The P and Q are the reflected rays, where L represent the line directrix on which the reflected point lies. The distance between F and L lie constant with respect to the wave being focused. The reflected wave form a collimated waveform front out of the parabolic shape. The ratio of local length to aperture size, known as F over D ratio, is an important parameter of a parabolic reflector. The law of reflection states that the angle of incidence and the angle of reflection are equal. This law, when used along with the parabola, help the beam focus. The shape of the parabola, when used for the purpose of reflection of waves, exhibits some properties of the parabola, which are helpful for building an antenna using the wave reflected. A typical parabolic antenna consists of a metallic parabolic reflector with a small feed antenna suspended in front of the reflector at its focus, pointed back toward to the reflector. The reflector is a metallic surface formed into a paraboloid of revolution and usually truncated in a circular rim that forms the diameter of the antenna. In transmitting antenna, the radio frequency current from a transmitter is supplied through a transmission line cable to the feed antenna, which convert it into radio wave. The radio wave are emitted back toward the dish by the feed antenna and reflect off the dish into a parallel beam. In receiving antenna, the incoming radio waves bounce off the dish and are focused to a point at the feed antenna, which convert them to electric current which travel through a transmission line to the radio receiver. The operating principle of a parabolic antenna is that a point source of radio wave at the focal point in front of a paraboloidal reflector of conductive material will be reflected into a collimated plane wave beam along the axis of the reflector. Conversely, an incoming plane wave parallel to the axis will be focused to a point at the focal point. Properties of parabola. All the wave originating from focus reflect back to the parabolic axis. Hence, all the wave reaching the aperture are in phase. As the waves are in phase, the beam of radiation along the parabolic axis will be strong and concentrated. The feed antenna at the reflector focus is typically a low gain type, such as a half-wave dipole, or more often a small horn antenna called a feed horn. In more complex design, such as the Cassegrain and Gregorian, a secondary reflector is used to direct the energy into the parabolic reflector from a feed antenna located away from the primary focal point. The feed antenna is connected to the associated radio frequency transmitting or receiving equipment by means of a coaxial cable, transmission line, or waveguide. The primary reflector is a paraboloid, while the shape of the convex secondary reflector is a hyperboloid. The geometrical condition for radiating a collimated plane wave beam is that the feed antenna is located at the far focus of the hyperboloid, while the focus of the primary reflector coincide with the near focus of the hyperboloid. Usually, the secondary reflector and the feed antenna are located on the central axis of the dish. However, in offset Cassegrain configuration, the primary dish reflector is asymmetric in its focus, and the secondary reflector are located to one side of the dish, so that the secondary reflector does not partially obstruct the beam. Working in Cassegrain antennas. When the antenna acts as a transmitting antenna, the energy from the feed radiates through a horn antenna onto the hyperboloid concave reflector, which again reflect back onto the parabolic reflector. The signal gets reflected into the space from there. Hence, wastage of power is controlled and the directivity gets improved. When the same antenna is used for reception, the electromagnetic wave strike the reflector, get reflected onto the concave hyperboloid, and from there, it reaches to the feed. A waveguide horn antenna present there to receive this signal and sent to the receiver circuitry for amplification. Advantages. The feed antenna and associated waveguide and front-end electronic can be located on or behind the dish, rather than suspended in front where they block part of the outgoing beam. Another advantage, important in satellite ground antennas, is that because the feed antenna is directed forward, rather than backward toward the dish, as in the front-end antenna, the spillover side lobes caused by portion of the beam that miss the secondary reflector are directed upward toward the cold sky rather than downward toward the warm earth. Dual reflector shaping. The presence of the secondary the presence of the second reflecting surface in the signal path allow additional opportunity for tailoring the radiation pattern for maximum performance. Another reason for using the Cassegrain design is to increase the focal length of the antenna, to reduce side lobes, among other advantages. The longer focal length also improves cross-polarization discrimination of off-axis feeds, important in satellite antennas that use the two orthogonal polarization mode to transmit separate channel of information. The disadvantage of Cassegrain antenna. The subreflector of a Cassegrain type antenna are fixed by bars. This bar and the secondary reflector constitute an obstacle for the rays coming from the primary reflector in the most effective direction. However, there is a possibility to avoid the disadvantage of the shadow, as it is practiced for example with the antenna of the tracking radar of the Skyguard of Arlington, AG. The secondary reflector reflects only horizontally polarized wave. The primary reflector, with its metallic surface, reflects all electromagnetic waves. A special feature, however, is that when a circularly polarized wave is reflected, it has a reverse direction of rotational after reflection. To summarize, a Cassegrain antenna is like a parabolic antenna. So due to the high gain and pencil-sharp beam width, they are mostly used for point-to-point link and mesh network terminal. In a transmitting antenna of a cassegrain, radio frequency current from a transmitter is supplied through a transmission line cable to the feed antenna, which convert it into radio waves. In a receiving antenna of a cassegrain, the incoming radio waves bounce off the dish and are focused to a point at the feed antenna, which convert them to electric current, which travel through a transmission line to the radio receiver. And that's the end of the presentation.